Kick us off there, Rick.
Okay. Well, thanks everybody for joining us today. As title said, we're going to be talking about machine learning and AI opportunities in construction, and we're really going to be focused on the practical aspect of AI in construction and what that means. Current state and a little bit into what could the future look like. So as we highlighted, not a huge group of people with us today. So if you have questions, please use the question and answer. We'll be monitoring that. And if there's anything that piques your interest along the way, please type in a question or a comment. And we want to focus today's talk in the areas that are of most interest to all of you today. So we'll start with our, maybe go back and we'll just start with our agenda, and then we'll jump into introductions of both Melvin and myself. So a little bit more on the details. We'll be focused on the introduction, and we'll get into the construction project process, and that's going to sort of be the key piece that we'll be looking at as we move through the presentation, and really bringing that back to, okay, what parts of the process can AI help and ML help? We'll get into data sources and companies, and that means external and external data, and then we'll get into some examples of incident prediction, things of that nature. We'll use safety as a starting point, but we'll have other examples. So we'll sort of tell stories about our time in construction, and since both Melvin and I are involved in AI, ML, and analytics, we'll sort of talk about how what we've seen in our time frame. So I'll give a bit of an introduction to myself, and then I'll turn over to Melvin to talk about his background. So my name is Rick Dowell. I have a mechanical engineering background. Spent time in a fabrication shop early in my career in Airdrie. I spent time as a facilities engineer at ConocoPhillips. Went back to school. I have a master's in business in technology commercialization. From there, I spent 5 years in an unregulated part of EPCOR that did streetlight, traffic signal, and LRT construction and maintenance. Ended up as a director of that business unit. And then from there, I was a vice president of operations at a large HVAC refrigeration construction and service company in Western Canada. And then about 4 years ago, I am a co-founder of Pontem Innovations, and Pontem is focused on helping organizations utilize their data more effectively through automated dashboard analytics and process automation. And lucky enough to be working with Melvin over the last couple of years on a handful of projects. And Melvin, please go ahead and give a background on yourself.
I'm Melvin Newman. Started out my career in Ottawa, if you forgive me, working in construction, mechanical engineering technologist, diploma. And then, really growing up in Ottawa, was big tech focused city during my high school time, and wanted to get into more of the technology, computer science. But the first dot-com bubble kind of popped that dream. And my dad suggested going into construction in mechanical engineering. So went in to do that, and started out in project management, moved into estimating, and fairly quickly realized that construction is a very traditional, we'll say, processes and ways that business is performed. Fairly old school methodologies. The first time I went to go do an estimate, it was all pen and paper. Realized that this was a really kind of backwards way of doing things. The companies I worked for were really open. So kudos to my mentors for allowing me to explore kind of the technology applications in construction, and moved into virtual design construction, moved across Canada out to Calgary here, and continuing working for a number of major construction firms then in Western Canada. A few years ago, started PataBid. So one of the challenges that we'll discuss it further on as an example, finding bid opportunities. Realized this was a major challenge in my career, automated it using machine learning. Then one of my college buddies took a look at it and said, hey, we should start a company with this. We did that. A couple of years in, met up with Rick, and as Rick said, we've kind of worked together, gotten to know each other. We've done some projects together on kind of the data analytics, machine learning side. And we both really share a passion for bringing this technology into construction. We both see construction as a ripe grounds for innovation, because it's been so far behind. And as we'll get into, machine learning has so much potential to help construction companies digest the massive amounts of data that they deal with. So with the intros, go ahead, Rick.
Yeah, for sure. I think a key thing we want to do, maybe just to set the tone, and Melvin, I'll ask you maybe to talk just a little bit about, the practical nature of ML in construction and what that means, right? Because often, if somebody's getting a PhD in machine learning and AI, you move into a theoretical space pretty quickly. But from a construction perspective and practically how people are going to use machine learning, I was wondering if you could talk about how you see that happening, and even what's being done right now related to
Absolutely.
tools. Yeah.
Yeah. So machine learning, as you said, Rick, when you're going in university, going through getting, a master's level, doctoral level for machine learning, AI, those kind of aspects of it in data science, you get a very theoretical foundation. But when we're building things in construction, we're literally building things. So the end goal is a building. It's a plant. It's one of these aspects. Now, that tends to be the focus in construction. But as we move along, as we target, finishing these projects out, building these buildings, there is a phenomenal amount of data in there. And in construction, oftentimes we don't even realize where that data is being generated, how much of it's being generated there. And even less so, we don't have the tools necessary to analyze it. It's been improving a little bit in recent years. I'd say in the last 5 to 10 years, companies, especially kind of the larger organizations, have realized some of the data that they're generating and how valuable that'll be. So they've started to centralize it. But that's just led to actually more problems, because now you just have this massive steaming pile of centralized data, and you still don't know how to digest that down into actionable results. So at the end of the day in construction, it's about the action. But how we get there is the data, and how we digest that data and turn it into those actions is where the machine learning comes in. I know we've talked about this, Rick. What are your thoughts? Like, where do you see machine learning with the human touch?
Yeah, I really like what you said there about that idea of, hey, collecting data. There's all this data in construction already. Highlighted that it's usually complex and it's usually unstructured. But this idea of just collecting more without the goal of like, well, what's the action item? What's the thing we're trying to track? And if we found out X, we would go down road A or road B. That's pretty important to know. Otherwise, you're just constantly collecting things without really being sure what you're going to do with it. And in construction, you're not, margins are tight. It's not a world where it's like, hey, we'll do some experiments and see what happens. You need to really be able to say, this is what we're going to do with this data. And I think one of the things that we both agree on in our conversations is that machine learning enabled tools, or tools that really use AI, is where construction can really benefit, right? Is that there's going to be tools that can make predictions, but also be able to make life easier on the job site or for the management of projects. And AI is going to really make a difference in terms of the flexibility and effectiveness of those tools. So I think that's part of the future. And I think we're going to discuss as we move forward some of those areas.
Exactly. And I think you've touched on it there, Rick. Construction is still very much a human to human environment. So AI in construction, machine learning in construction, it's going to be about assisting the people. There is a bit of pushback in construction right now with machine learning. They're like, oh, it's going to go and replace all the people. We're not there. It's questionable, philosophically, if we can get there. But at present, it's all about helping people do more with less. And I think, as you also mentioned, Rick, the research aspect of it, construction companies aren't well known for being R&D centers, but I think that's a great intersecting point for academia and business. You know, if you're going through for research, if you're looking to put together a thesis, teaming with a construction company can be very mutually beneficial.
I think that's a great point. So let's move on to the next slide, and we'll talk about the construction project process. And we have four main areas that we want to focus on, and the data that comes out of those. And ultimately, you know, if you're in construction or you're somebody who's interested in machine learning and how that could be applied to construction, we'll talk about what it looks like in each of these areas. And we'll tell some stories about our experience and how we can see this being beneficial. And like we highlighted, if there are any questions along the way, please do fire them in the Q&A portion in the bottom of your screen. So we'll start here with the opportunity on procurement side of things, right? So that idea of sourcing, probability of winning, competition, like what that looks like. And ultimately, I mean, PataBid has spent a lot of time on this, and Melvin, your career has been in estimating, and you've seen obviously the importance of making sure you're clear on what it is you're bidding and what your capacity looks like and the scope, right? And yeah. I had two in my time in construction, I had two separate estimating groups report up to me. And one of my favorite stories was when we would, you know, you put all this effort into bidding something, right? And let's say your win rate's 15 or 20%, that's pretty good. So you think about like 80,
that's really good.
85% of your time is spent on something that isn't going to be successful. And then we would have times where we would win, and you'd be like, guys, we won, like, great news, everybody. We won this job. And the people that estimated would look at you and be like, really, we won that? Oh no, we're going to have to go take a look at that. And now that's a problem, right? So it's about, so Melvin, I want to hear more about your experience around how you can use your time more effectively in this space when you're estimating, right?
In construction, it starts even further in front of that. It's simply finding the opportunity, you know, making sure you're not missing something, because there is so much out there. And when at PataBid, when we started down this path, the idea was to try to automate the sourcing of these procurement projects and bid opportunities for construction companies. And when we started out, we had a glitch in our code. This was a few years back over Christmas, and the system went wild and it grabbed every procurement opportunity. And that's when we realized, good grief, we have a monstrous issue here. There are on average in Canada between 1,000 and 2,000 public procurement opportunities issued per day. And that runs the spectrum from buses to medical equipment to construction projects. So for your business development team at the front end of a construction company to find these opportunities is incredibly difficult. And it's always spread out over numerous different platforms. So we built into PataBid to centralize all that. And then we realized we needed machine learning to sort this, because there is no way to feasibly do this as a human and not make a tremendous number of mistakes. And that was really out of my career, what was happening when we realized this. We're like, okay, we're missing opportunities in the job that I was doing. We need to actually get on this and make this, automate this somehow. And so that's really where, right at the front end. And then as you were saying, Rick, the average in Canada right now is 1 in 10 projects. So if you're doing 15 to 20% win ratio, you're doing really, really well in construction right now. So you want to target your resources. So the front end of a mid-size construction company will have 5 to 10 people who work in estimating. And so that is a pretty heavy investment for no direct revenue coming in. So, these people are a cost center. So you really want to make sure your investment is secured. So using data analytics, using machine learning to start to predict where you're going to win. Where is your, as the construction company's, greatest success area? So that is a huge application right there. And then, a lot of that takes closing. the data loop. And we'll cover that a little bit later on for, knowing which projects you're successful on, but also which projects complete successfully. And all of that can be fed back into the front end of business to capture the data on your performance, understand your performance, and then develop on that for you the greatest success for that company.
Yeah, I think that idea of there's all these things for you to bid on. So an action item maybe for anybody on the call who's in construction is a question that you could take back is, well, how do we decide what we're bidding on? How do we make that call? And how, we always talk about data and let's say machine learning, but data especially is there to assist you in decision making. It doesn't necessarily make the decision, but it's there to assist you. And if the answer is, well, we're not using data that much, it just comes down to somebody's opinion that day on whether or not that's a good job, there's probably some room to optimize that. And that means optimizing what you're bidding on, and then highlighting in this slide, we can go further down into operations and all the different data there. But essentially, before we dive into the details there, I just want to highlight that tracking what actually happens at the end of jobs and how big of a variance you have in outcomes is really important, because it's easy to remember either the really good jobs or the really bad jobs. But that doesn't mean but what should you be bidding? What is there a tighter range of potential outcomes, and that you can plan and have some profitability and schedule clarity and consistency, right?
And understanding what makes a job successful also. Like that's so critical in there.
Yeah. So that's the data side of things. And we'll have a slide after that shows sort of just a quick screenshot of some examples of the open tender and AI. And here it is. So this gives you an idea of what does this look like practically, right? Well, in the background here, here's a bunch of jobs that are open as of May 23rd, and you can see the breakdown by sector. And so this is a great example of machine learning practically being used to classify and look at jobs, right? So there's a piece of data analytics around this, like tracking what region, if something's in Alberta or something's in a certain city or a certain owner. But that machine learning piece around breaking it down by sector, that's virtually impossible to do, like have a person do, right? So this is really insightful and helpful in terms of saving time and giving people better information to say, okay, is it construction? And then we can't do it, we won't bring it up today, but you can imagine within construction, you can break it down. There's another 5 different sectors, and you can break that down further. And now you're getting into a level of detail that's really helpful. If I'm construction company ABC, it's like, what exactly do I want to bid on? I want to know
what do I want to target. Yeah, exactly. So, and this will actually give you an example right here. Like this is a fairly filtered dashboard here, but you'll see in here on this given day there are hundreds upon hundreds of open opportunities. So finding that needle in the haystack is absolutely critical. And part of the problem too is the people that publish these open opportunities aren't necessarily intimately aware with what they're actually buying. Yeah. So they'll, in one day, that buyer for, the city of Ajax or the Department of National Defense might buy, military boots, might buy ammunition, and then might buy high-vis vests, and then put out a construction project for an office building. So it's very common, and this is something that we actually found in our data analysis with the AI working on it, is the amount of stuff that you can miss simply because the buyer didn't necessarily understand and published it in the wrong area. So this is again where massive amount of data, using the machine learning to help refine that down so that the people in charge of going after this can find what they're looking for and target it explicitly.
Yeah. So maybe if we could go back one slide, Melvin, let's go back to, I just want to highlight this a little bit further because we talked about the business development side, but I want to talk about operations and commissioning and get your thoughts on this. Because one thing we hear from people who, or organizations who want to start using their data, they know they need to, they have a bunch of data, but they're like, it's not very good. We don't have very much data, or it's messy, or it's incorrect. And I want to challenge that a little bit, because for construction especially, the amount of information that comes in daily is huge. And I think people underestimate how accurate the information is going to be. So if you just think about the project itself, you usually have some sort of work breakdown structure. You know what the scope is, you know who the client is, you know where the work is. So there's all these static pieces of the project that, if you can be consistent in how you classify, make a huge difference in terms of helping AI or the machine learning say, okay, this is the bucket or the characteristic that I can put on this type of job. And then on a daily basis, you're going to do safety reporting. That is going to be accurate. Payroll is going to be accurate. People don't come up to work. It's amazing. You can guarantee that if somebody worked hours and didn't get paid, you're going to hear about it.
Yep.
Everything that gets bought for the job, same idea. You have POs, you're tracking when that stuff arrives, who you bought it from, how long it took to get delivered. Like most of the financial tracking pieces are there. And so then
the challenge on that one is, though, Rick, is where is it? Because you've actually hit the nail on the head there. Like, yes, like safety is always going to be very remarkably accurate. Financial package, remarkably accurate. The two are at probably opposite ends of the IT spectrum for where that data sits.
Sitting in an Excel spreadsheet on somebody's desktop.
One of them will be exactly. The other one might be on a network share, and one will be in JD Edwards or SAP.
Yeah. So I think, so another action item for you on the call is, because one action item was how to decide what you're bidding and really thinking about, are we using data? Another one is to think about what are the key things that really matter most for our project. When you're talking about tracking around productivity, profitability, and then you can think about where is that information right now? And if you can start to get a handle on where it is, because it's somewhere, and start to have that in a place that's consistent, you can start to say, okay, like I'll use the example, and Melvin, you can agree or disagree with me, but I often talk about, if using data and digital transformation is a 5-step process, step 5 is AI and machine learning. And there's so much cool stuff that can be done there. But steps 1 through 4 is understanding where your data is, understanding what you're trying to achieve, and then automating those processes to make sure that you can get the data. Because now you've opened up a world where you can really use it. So I'm curious your experience with that.
In my experience, all data is good. It's just how much you have to polish it to make it good.
Right.
Diamonds come out of the ground and they're actually pretty ugly. So where I see AI being applicable, though, is not just at step 5. I think steps 2 through 3 and 4 have different variations of AI. Right. So step 5 AI is absolutely like that's your prediction. That's where you're starting to get that analysis, the very high level. But consolidating the data is a huge application of AI. For example, pretty much every single construction company, almost no matter how big or small they are, has a network shared drive. And the vast majority of data on projects ends up there before it ends up in the financial package, before it ends up, and it's stored in Excel sheets, it's stored in PDFs. Consolidating that steaming pile of data, digesting it, is a massive application of AI right now. And that is, I think, the first step that we need to go, because you've hit the nail on the head there, Rick, with the kind of hinting at the process side of things and having the human adapt to the process. My personal opinion is always the machine should adapt to the human, not the other way around, because we humans are exceedingly difficult to standardize. So if we have the machine, it's a way harder problem. But if we can have the machine start to adapt to the human, then it starts to proceed much better.
So maybe let's jump forward a couple slides to the construction project process, and we'll talk about execution. And so execution, it's a big, jobs can take 3-4 years. Sometimes jobs can be done in a couple months, depending on what you're building. But that constructability, scheduling, budgeting, and execution, and ultimately all the work that's done on the ground is a key component where there's a huge amount of data. So let's maybe give some examples of some of the areas that can utilize machine learning and the tools that are available, and then we can talk about what that means from a cost influence curve perspective. So, I think natural language processing is a good example, right? You're trying to get daily field reports and somebody's got to consolidate that and get it into a usable format. Well, AI can definitely do that for you and get it structured very quickly, because you're paying a superintendent whatever you are an hour, right? It can be significant dollars. And then you're asking him to, hey, would you mind typing this out, or make sure you write this down and then get it over to an admin person who can type it in, just so people can see it. Well, can you automate that, right?
Yes. And can you take that to even another level? Like, something that nobody thinks about is in construction is the emotional aspect of it. How is the team performing? And that goes towards using AI as an extension of the sentiment analysis AIs that we've been developing. So as and I don't mean internally here, but as an AI group, sentiment analysis has been a huge area of research. Well, applying that to a project and understanding, okay, how is the team actually working together? Is this executing properly? Are there elevated stress levels when they start to fill out their reports? And you can pick that kind of stuff up with the natural language processing. Like, from the language, you can start to pick up how the team is actually working together and gelling. And then you can start to identify, okay, how do I turn every team into an A team on these projects?
Yeah. And I think at static job sites, there's opportunities for cameras that can track how many people are on site, what their movements look like. I'm not an expert in that space, but I know there's some cool stuff happening around that. And I was wondering if
there is one of the ones that I actually looked at. I mean, there's a lot of challenges around that. And again, it goes back to the human aspect. An early touch point on this is fab shops. Like, you worked in a fab shop, Rick. You mentioned early on. Using this may sound creepy. I don't personally think it is, but yeah, I'm open to pushback on it. Using the security cameras in the floor, like the shop floor, and using basic image recognition classification, you can very quickly identify the key walk lines that people are taking, the key processes for when they strike an arc. You can pick that stuff up if you're in a welding fab shop very quickly. And you can use that information to a very high fidelity to drive the layout of these shops for maximum performance. And then inside that, you can start to identify, okay, where is my maximum performance? What are these people working on? What steps can I buy a new machine? I mean, I went through this with one of the fab shops I worked in when we were looking at investing in machinery. Where was the key point in the process? Because you obviously can't buy all the machinery. That's tens of millions of dollars when you're investing in these shops. But which one would give you the best benefit? And it was as simple as, personally, I stood at the window and watched for a few weeks what was going on the shop floor, and then was able to make the recommendation, like, okay, here's where you are spending the most amount of time. If we pick that process to automate, it will give you the best benefit. So that you can automate that, though, rather than having me stand there at a window watching it, which is some people think that that's less of an issue than using the cameras. That's an open debate.
Yeah, a great example, right? If you're going to be focused on continuous improvement, wherever it is, what type of tools, ML and or AI enabled tools can help with that instead of having a person do it? Let's set up a camera. Let's start tracking this and get some more structured data from it. And
it goes to reporting. Like, if you need to know, especially in the fab shop, it was a fascinating research project that I did kind of off the side of my desk to see, okay, striking the arc, how much time is actually spent welding? And in a fab shop where you're doing welding, that's actually where you make your dollars. Everything else in the shop is to lead up to that. So how do we automate that so that the managers on the shop floor could quite literally pull up a dashboard and know how much welding they're doing in a day, what's the steps that get them there, and how can they speed it up so that their welders are running as many hours of the day as possible?
Yeah, exactly. So maybe let's keep going, because I want to weave this idea of risk into our conversation and some of the stories. We're going to tell some stories here about our experience, and risk is such a key part of that. And I want to use this cost influence curve to identify this. Anybody who's been in a construction project has probably had the experience that you're on site, you're doing work, and an issue arises. And if you had heard about this issue a month earlier, you probably had 3 or 4 options in terms of fixing it. But because you heard about it when you did, you actually had 1, maybe 2 options, and probably neither of them were very good. And so you're just in full on firefighting mode. So that cost influence curve is all about how do we spend more time and effort up front to plan out and make sure that we have things in place, but maybe more importantly, early identification of issues. And so we talked about all that data that's coming in, but as a project manager, I can say you're a little behind in terms of getting the data. And then the other thing that happens is you're usually optimistic about, oh, we're a little behind, but we'll make it up. Don't worry, we're going to be fine.
Famous last words.
And as a PM, I said it. And then as somebody who was leading a group of PMs, I heard them say it. And you start to realize, like, you're not really going to make it up. No. And so this piece is, how can you start to learn where your issues are earlier on, right? Because when those 2 lines intersect, that's usually right around when you hit site. And you can see you've already spent a ton of money, and your ability to influence cost is starting to decrease significantly. So it's really important you learn as fast as possible. And I think there's a lot of opportunity for AI to help in this case. And I'm going to give an example that would help crystallize this. So I said before, I worked in an organization that did a lot of streetlight work. Well, this organization had actually done streetlights for 80 years, almost 100 years. So you can imagine how many different streetlights they've seen, how many times they've installed. They should have, if they have all this data, they would have had enough that you could use machine learning, and it wasn't available back then. But now if you had all that, you could start to track at least the variance and the risk associated with different projects, right? And even within streetlights, you're like, streetlight's streetlight. But if you look deeper, there's streetlights that are on, a freeway, right? That's very different than a streetlight that's on a busy street. Let's say 170th Street here in Edmonton, versus one that's in an alley, versus one that's in a residential. And you can decide certain scenarios you're going to have to do the work at night. Other ones you're going to have to do the work maybe on a weekend. And if you have all those tags of the projects, you'd very quickly be able to take all that information and say, okay, here's an average cost per streetlight, and here's the variance on different jobs. And then you could have different characteristics to say, and here's exactly what the characteristics mean. Is that a 10% increase or a 10% decrease in productivity? And you'd have a really good starting point to say, on average, this is what it should look like. And so very quickly, if you started putting in at the very beginning of a job of, let's say, 100 streetlights, and you started putting in the first 5, and your average was lower than or higher than what you expected, you could be like, whoa, time out, what's going on? Right? But if you don't have that data, then it's easy to say, oh, every job's different. Every job, there's a story. And it's true that every job has a story, but it's never as unique as the people on that job like to think, right? And the streetlight's a good example. If you've been doing streetlights for 80 years, you probably have a pretty good handle on what it's going to look like. Yes, we've done it when it's -20. Yes, we've done it when it's +30. Yes, we've done it in these scenarios. So I think taking that data and trying to get the learnings out of that using an Excel spreadsheet or using basic analytics, really difficult. But I think machine learning can really fast forward that and automate it. And so, Melvin, I'm curious your
and machine learning has the capacity to integrate variables in that we just wouldn't even think of. Like you said it there, we've done it at -20, we've done it at +30. Okay, but what is it today? Or what is it tomorrow? So now you can start to predict, okay, and you can start to get ahead of that curve right to the point of the estimate. So you can pull out of the estimate, okay, when is this thing supposed to happen? And that's a famous one. Good story that I had was in my estimating. I was putting together a project, and I had read the documents and realized that this project was supposed to take place in the dead of winter. And I sent this out to, a number of people to price the digging on the project. So the excavation, pull it out. Well, I get my price back, and it's psychotically low from just what I know from my experience. So I called the guy up, and I'm like, and of course, in estimating, just so everybody on the call knows, you don't get your price from people until, if you're lucky, 30 minutes before it closes. Like everybody likes to hold their price so that nobody has to talk about it, and it is what it is. But I called this guy and I'm like, where are you at, man? Like this seems incredibly low. And he's like, nope, no, it's all good, all good. And then finally I asked him, like, do you know when this project happens? And he had missed that part in the spec. And I was like, oh, I'm anticipating it takes place next summer. I'm like, no, it takes place in January, February. That ground that you're going to be digging with that small excavator, you actually need a massive one to break through all of the frozen parts. And so then, of course, the price went up by a factor of like 3 or 4 when we got it in. But that goes to show you the risk identification at the very front end. And then you can carry that on through. It's like, okay, so as you were saying with the street lighting there, Rick, like, you've done this so many times, you have a large data set. Well, now when the next one comes in, you can have machine learning very quickly identify for you where you either, like, depending if you've costed these out so many times, you could have it start to predict the range that it should appear in. And that becomes huge in street lighting. When I worked for one of the major companies in Ottawa that did all of Ottawa's street lighting, they may actually still do it. That was actually a really unique data set that they had. Now, at the time, we didn't have the technology to really do what we're talking about here. But today, you actually could take that and you could use it to start to predict with a very high accuracy what this is going to cost. And because machine learning has the ability to learn, it can adapt. So one of the fascinating things we ran into with our machine learning on PataBid was when COVID happened. The machine learning algorithm that we had no concept of what COVID was. So when things started to happen, like, RFPs were coming out for masks, for gloves, and all of them were about COVID, it was a shock to the machine learning algorithm, but it only took it about a week and a half to adapt to it and to learn what it is. So they have this ability to bring in all of these variables and learn from them. So you can have it as a continuous learning process for an AI to backstop your estimators and to backstop your PMs. So when they go out to do that service call, they know more walking into it than they ever knew before. And they also have an idea of the expected outcome.
Yeah, and actually, I'll tell a story on that too. Why don't we keep going on a couple more slides, and then we'll jump in on that piece related to commissioning, I think, because we just want to highlight a little bit around the internal and external data sources, and just highlight data sources inside the company. The performance metrics, that's productivity, safety. You have your financial performance, which usually sits in an ERP system. Then your pursuit performance, which is really about bidding, CRM system, and just all this is usually internal and to your company. So it's actually a competitive advantage if you have this information and readily available. But also want to highlight, often those metrics are lagging a little bit, right? And then if you go to the external one, which is the next slide, same idea: project lead generation, market analytics, competition metrics. These are actually lagging even further than the ones than the metrics you would have internally. So it speaks to the importance of, well, how can the little bit of information we have and getting into predicting, are we on the right track or not? Because if you wait, if you wait a month or 3 weeks for all this information to come in, sometimes that's too late, or at the very least, it's really reduced your options on jobs. So you have to be super proactive. And I think the range piece that Melvin, you talked about, is really good, right? Like AI, if you think of it in terms of telling me where should I be when it's predicting where your ranges are, that's what you want, right? Because in construction, so much of the game is you do all this good work on 95% of your projects, but then you have your 1 or 2 projects that get away from you, and those eat away at the profit from all the other good projects, right?
Severely, yep.
And I think a lot of, especially large construction companies, they feel that, like, that's their goal, is how do I make sure I don't have any runaways? Because we're going to have our good projects, we're going to do okay. It's how do we make sure that we're not getting out over our skis on a couple big projects? And I think machine learning can really help with the early identification of
absolutely. And I know there has been some work in this area. The challenge, though, is, as you've mentioned there, Rick, the the internal versus the external data. The internal data tends to be nicer. It's still ugly, but it does tend to be nicer than the external data.
You can control it at least, yeah.
Exactly. And it does tend to be formatted better. So it's always the first target for the research projects and the machine learning coming in. But one of the challenges, I should say, with machine learning is you have to be so incredibly careful not to bias it. And if you're only showing it internal data, you're going to bias it to your own company's flaws, your own company's successes, and it won't actually be able to help you at all because your own company is only one of a drop in a bucket. And so you need to bring in all of this data, and it is a major undertaking, but you need to be able to bring in the internal data, the external data, and actually blend it together so that you can know, okay, this is how I can perform internally. This is what I can know about my competitors, how they perform externally. How do I bring this together to predict where the best place is? And it is a very complex process, but it's very doable. Like some of the stuff that Pontem's working on right now with their dashboarding and such is leading down that path. So you can start to get that external data. Then we get to step into the predictive portion of it. It's like, okay, where is the best place to be now? And some of that goes to really obscure data sources, population counts. So you can start to see where, the most money is being spent at a high level with the least population centers. And you can start to identify, okay, the least amount of competitions in these areas, it may be a good place to go move to. So there's a lot of enablement on that, and it all comes from both that internal and external data and understanding where that resides. So internal data can be everything from your network shares to your ERP systems. External data can be everything from census data to job performance in the marketplace. So public procurement is a famous one because there's so much there. Yes, even
weather data.
Exactly.
External pricing, like pricing of material. Often there can be lots of public data sets on at least commodities, right?
And it's fascinating what you say there, because so much of that data is available. Yeah. So you can get commodity pricing, but you can also go and get pricing right off of Home Depot's website. Yes, it's very condensed, but you can also get pricing now with all of the e-commerce sites going. You can get pricing from any of the wholesalers, any of the major players, and from there you can start to feed that right into your projects. And if you keep the history of that pricing, you can start to trend where the future is going. And yeah, you're gonna say something there, Rick?
Yeah, no, just totally agree. I mean, and that's an AI tool, right? AI enabled tool where they're going and it's scraping data from websites, but it's doing it in a much smarter way than what would have happened 5 years ago.
And it's able to bring in more. So you can actually start to bring in right from news sites. Like I'm getting off on, kind of my wild vision of how this is applied, and some
we were going to talk about where
I'm going with it.
So maybe take 2 minutes and talk about that, and then we'll keep going about commissioning.
But if you can start to monitor, news, global events, you can actually start to feed that into your pricing at, from the suppliers, and the machine learning can start to blend that together to start to give you more accurate predictions. It's similar to predicting the weather. If we don't have the technology yet to achieve this, but if you can get enough measurements in, you can start to more accurately predict the outcome. So yeah, I'm gonna stop there because I could go on for a very long time on this, as you know.
Let's keep going. Why don't we jump through it? I think just highlight, we know the importance of early identification, and machine learning can really help there. But why don't we keep going into the commissioning piece? And I think, for often, I think there's a lot of people in construction who, they build a job and they go away, but there's a lot of organizations that are building things and they have to operate it. Mm-hmm. And that commissioning and operations is important. And I think there's a huge opportunity in that space to track what's happening from a maintenance perspective on your job. So I had highlighted before, I had worked at a HVAC service company, and you can imagine how, if you're a technician and you're walking into a job, the general standard state is you have no idea really what you're walking into. You know, there's an issue, you're not exactly sure what it is, and away you go. And so that's why it really helps if you have a lot of experience, or you have, you know, the foreman or somebody in your team. It's like, oh yeah, I've been there, I know that site, here's some issues. Well, what if you had all that data and it was collected, and you're utilizing AI and that data to help predict what the issue is. And so I'll use an example. Like if you're tagging certain clients and jobs in a way, it wouldn't be that hard to pretty quickly say, okay, we know what time of year it is. So let's say it's July. Well, okay, we're probably not having a heating problem, we're having a cooling problem. Okay, here's a type of building that I'm going into, and this is a client. Okay, so we know probably what's in there for equipment, and maybe you've even gotten to the point where you've tagged all the equipment for the clients that you service. So now you're saying, okay, I know they have these types of air conditioning units and condensers, whatever it might be. And then you could take it another step further and say, okay, we actually service these types all the time, and here's the standard problems that come up. Here's the top 3 issues that we've seen over the last 5 years. And so using machine learning to help figure that out, you could actually go in and say, here's a prediction on what we think the issues could be. Now, if I'm a service tech, I'm not going in being like, gee, I wonder what I'm going to find. You're like, okay, I bet I should keep an eye out for these 3 things. And so what is that worth, right? If you're able to identify and get people up and running, could you charge a premium? And how much better is your work for your people? Like, I think there's a huge opportunity in terms of
and understanding. Yes, like you're right on it there. And being able to use that to start to predict, okay, you know, in Calgary, for example, or in Edmonton, you know, out of the 20 buildings that I service, 5% of them or 10% of them or 20% of them use, you know, XYZ manufactured air handling units. Well, I know from the ages of these units, which ones have what problems. You can start to identify that information, and then you can start to stock those parts. So suddenly when the chiller goes down or the air handler goes down for something, you as the company may be the first one called simply because you're the only one in town who might have that part. And rather than waiting 4 or 5 days in, you know, plus 40 outside heat, you could actually be in there and have them back up and running very quickly. And the predictive analytics applied to maintenance can help enable that.
Yeah, and another example that's I'm sure all of us can appreciate is you can see this with cars and automobiles, right?
Yes.
If you look at, you know, a 2015 Toyota Corolla, which you can imagine how many of those are sold, they know what the like here's the most likely issues that come up with that. You can even Google that and start to learn, oh, okay, this is what's likely going to fail.
Well, the mechanics get bulletins on it.
Exactly.
Like they literally, from if you're a dealership mechanic, you get bulletins on what most likely things are starting to go wrong. So it's been applied, like you said, in the automotive industry already. If we take that by extension to the buildings, and the buildings are even worse than cars. Like how many buildings do we have around that have been around for 100 years that have 50 and 60-year-old HVAC and electrical systems in them?
Totally. Yeah, like a huge opportunity, not to go off on a tangent, but just to say from a climate change and emissions perspective, those inefficient buildings, that's a huge opportunity. And I think from a constructability and maintenance perspective, we talk a lot about it now in terms of constructing new buildings, but what about existing buildings that could be retrofitted? And anyway, that's a topic on its own. But anyway, so we'll highlight the importance of collecting data even at that phase, and thinking about what does this mean from a maintenance perspective, and how can we start tracking and setting up our systems even at commissioning, say, hey, is this performing the way that we wanted? And so next, I think, well, 2 things. You know, we have 12 minutes left. We want to make sure we're getting everybody out right at 2. So we have a bit of an example around safety, because we know how important safety is in construction. It's not going away. It's only becoming more and more important. And how can machine learning help with that? So we're going to talk a little bit about safety, but, you know, please, just as a reminder, if there's a question that you have, please put into the chat or into the Q&A, and we're happy to jump on it. So Melvin, let's talk about safety. So I'll give a bit of my experience on the safety side, and you know, I've been involved in numerous investigations of varying degrees of serious outcomes. And the one thing I'd say is that each safety investigation, it has its own story. And you and I have talked about how there's so many different chain or links in the chain that if one thing had went differently, the incident probably wouldn't have happened.
Yeah.
So when you look at each one, it's like it depends on humans, it depends on conditions, etc. So the idea that machine learning is going to be able to predict this incident is going to happen is virtually impossible. However, much like we talked about the range of costs, the ability to identify using all of the history that we have around near misses, around safe worksite inspections, all those types of things. What are your thoughts around the ability for machine learning to be able to predict, hey, we're getting into a danger zone. We're moving from green to yellow to red.
Yeah.
And then there's an action item associated with that. Do you think that's possible?
Oh, A, I think it's possible. B, I think it needs to happen. Like safety is so critical. I mean, I'm getting a little bit personal on this. I have been, I know somebody who unfortunately passed away on a site due to a workplace accident. So this is absolutely critical. Everybody has a right to get home safely. So I think this could be a tremendous application for machine learning. And like you said, Rick, it's a challenge. I don't think that you could get to a point where you could suggest that, this is going to happen on this day. Otherwise, we'd be living in total recall. Like it would be we don't have safety precogs. We do not have safety precogs yet, no matter how much we'd love to. But being able to understand the nature of your project and as it's in that execution stage. So, a significant project can take 1 to 2 years to execute. And the safety environment around that project changes as it progresses between winter, between summer, snow and rain. You have all of these challenges that feed into making that project a safe work environment for your employees. And then on top of that, you have the history of it. Like where is this project happening? What are the conditions of this project? If we're brutally honest, we can get into, okay, are the clients on this project, do they have a noted safe environment? Like, are they supportive of this? Obviously, some of the most safety conscious clients are in the oil sands, are in the heavy industrial. So, BP out at the Jansen site, you've got, the Shell facilities. Like these are extremely safety conscious facilities as a nature of what they do. We need to take some of that. Actually, I would suggest we need to take basically all of it into the commercial sector. So yes, you don't have explosive materials maybe when you're putting up a strip mall. So we don't necessarily need to bring in, all of that kind of processes and procedures. However, you still have the issue of safety, even in a strip mall. And so having something that automates that process for the people in commercial, for the companies that are working in kind of these less industrial sectors, but bringing all of that knowledge in, absolutely, I think that could be a huge step forward as simply giving that red, yellow, green for your site. When you log in the morning, or it alerts you and says, hey, based on the historical trends, based on the models that we've generated around this, your site may be proceeding to an unsafe position. Yeah. And once you know that, and if you can get that early enough, okay, now you as the owner of the company can go there, visit the site, identify, okay, here's what's going on, and it becomes a cultural issue. It's all about the safety culture.
And that could even be part of tailgate meetings. Like, I don't think that would be something you could widely share with the group. So
exactly. And I think that, even if you were to notify everybody on site, like, hey, this site is stepping into a yellow condition, all of a sudden, everybody on that site is going to have a heightened sense of awareness.
Yeah, for sure.
And they're going to start thinking, it's going to remind them, oh yeah, we got to clean this up. We got to fix this up. We're heading towards something. And that could be right down to, now it's winter conditions. That automatically is going to put you into maybe a yellow condition, but triggering that in the human mind will have such a profound effect on maintaining the safety culture of the site.
Yeah, I agreed. So we have 5 minutes left. So maybe we have two quick, 2 slides left. I mean, we talk about closeout quickly. I just want to say here, I think everybody's had the experience of a project drags on, it goes on longer, everybody just wants to move on. And some of the lessons learned, the financials, even just the tagging of information, it doesn't get done to the level that you need. This is so important. If we loop back to the very beginning around using machine learning to identify where you're going to be successful, and just all the data coming back to help you predict what's going to happen next time, closeouts have to be done really well. And you have to have the data tagged and associated with the job in a way that is meaningful. So, you know, as an organization, if you want to use machine learning and AI and use your data effectively, it has to happen here, because this is the actuals. We can't live in this theoretical world of like, oh, this is what should have happened based on budget. Well, that's nice. What actually happened? Because that's where you're going to reduce your risk. And then,
absolutely. Yeah, no, you've hit the nail on the head there. I see that we're down to 5 minutes left here, Rick. So I'd suggest, you know, we wanted to talk a little bit about the future. What I'd actually like to do is throw up our contact information here, and throw it open to anybody on the call here who has any questions. If you have any questions, throw them in the Q&A or throw them in the chat window there, and we'd be happy to answer that. And while we're waiting for that, we can kind of talk about, where do you see the future going, Rick?
Sure. I think that the tools that we'll be utilizing machine learning will continue to increase and become less expensive. Like, I think it'll continue to be something that practically can be used on sites. I think any of the jobs that, you know, we talked about things where they're manual repetitive work, like I think machine learning is going to take on that, whether it's process automation, whatever it might be, that those are going to be removed. And I think in the future, the predictability around productivity and what should happen versus what did happen is going to continue to get refined very quickly, you know, and I think that will happen in the next, let's say, 3 to 5 years. Now, maybe I'm optimistic on the timing of it, but I don't think we're ever going to get into a place, like I think in fabrication, you're going to have more automated, you know, like automated machines and things of that nature that might use machine learning and are able, like true AI in terms of doing the work. But I don't think on job sites, I think we're a long way away from that. Yeah, so I'm curious your perspective on that.
You know what, I would largely agree with you. I don't think that, you know, quote unquote AI is going to replace actually building something. Like we still have to build things. And AI doesn't necessarily build things that way. However, I think absolutely we're going to see AI making inroads into health and safety. I think that's going to be a huge low-hanging fruit position. I think we're going to start to see AI and machine learning getting into more of the success stories of companies. In the, you know, we used AI for XYZ, you know, to help us bid better work, bid more valuable work, that sort of thing. I think we're going to see it also taking on more optimization. So virtual design construction, 3D modeling of buildings.
Yeah, I didn't even talk about that. Yeah,
I know that's a huge one. Being able to identify out of a 3D model a more optimal process, you know, a more optimal routing, or more importantly for people at the front end of the business, when you get a 3D model that's basically empty, using AI to start to fill in those blanks and using machine learning to start to fill in those blanks. I think that's going to be some of the early aspects of this.
Yeah, agreed. So
I've got a, do you see the question there, Rick?
I do, yeah. So the question is, what kind of algorithms are you using for safety incident prediction? What kinds of features do you input to the model when predicting the condition of a construction site? Yeah, good question. So
that is an excellent question. So this goes right back to tailgate reporting. So in depending on how familiar you are with the construction process, every morning the crew on site is to have a tailgate meeting, and they have to issue a report on that. And that covers, you know, usually all aspects of what's going to happen that day. So that gets fed in. And then you can take that along with any of the incident reports from the site. So ideally you won't have any lost time, but near misses are a big one. A site that has a large number of near misses on it is critically an unsafe site, even if you haven't had a severe injury.
Potentially though, I will say that if you're actively addressing it with near misses, because if you think near misses are happening anyway, if you're reporting on them, at least you could classify them and then say, is it slips, trips, and falls? Is it things dropping from height? Like, what are the nature of them? And I'd say those are some of the features, right, of a construction site, is what type of incidents are you seeing?
But statistically, if you, yes, you could be addressing these, but if they are happening over and over again,
true,
you know, if you have one near miss and you address it, you know, bring everybody together and organize it, and it doesn't happen again, yes, I would suggest you've solved the problem. But if you're having several of these, the problem is more deeply rooted. So pulling that in, blending that with inputs like the weather. Weather has such a huge factor, especially if you're in greenfield construction. So when you're doing that high rise downtown Calgary, or you're working on the Stantec Tower in Edmonton there, when you're building those as greenfield, when you have 30-40 km/h winds, that is naturally a less safe site, and it has to be addressed. So those are the kind of inputs that we would be feeding into the model to start to get out, okay, here's the condition of this site on this day.
Okay, so I know everybody has a full schedule, and I think we're at 2 o'clock here. So thank you for your time, and I encourage everybody, if you have any questions, to reach out to Melvin or myself. We like talking about this. We're happy just to have a general conversation about what this could look like. And you know, obviously somebody like Melvin, who's experienced in the details of construction, but also is, you know, expertise in machine learning and practically bringing that forward is really valuable. So
thank you, ladies and gentlemen, for attending today, and hopefully we'll be in touch in the future. Thank you very much, Rick, too, for joining me on this.
No, thank you, Melvin. That was fun.
Take care.
Bye.